Hello, my name is Daniel Crenshaw, and this is my Lab 2 report. The purpose of this lab was to track the motion and trajectory of a falling object with a video tracker, and then compare the results with a Python program that simulates the same scenario. The main physics principle used in this lab is Newton's second law, the momentum principle, along with the drag principle. Here is the main outcome of the experiment. The graph depicts that the observed trajectory, based on the video analysis, is similar to the predicted trajectories to a certain degree. One of the main formulas used for this experiment was the position update formula. This formula allows us to determine what the new position of our object will be based on the velocity. We also use the velocity update formula in order to properly track the trajectory of the object. For part of the coding aspect of the experiment, we utilized the drag formula to simulate the air resistance on the object as it was thrown. Some other important details for this experiment include the system, the surroundings, and the initial conditions. The object that was used for this experiment, a paper ball, is the system, and everything acting on the object, like gravity and air resistance, is the surroundings. This is because the thing being studied is the object, which makes it the system. One of the initial conditions for the coding aspect of the lab was making sure to perceive velocity as non-constant. This is because the object was being affected by other forces, unlike the Lab 1. Now here's a video that was used for the
I
experiment.
did it.
While analyzing the video, it was important to determine the orientation. If I were to flip the orientation, which would essentially flip the axes, then the x values would be negative instead of positive. And here is the code that was used to simulate the data. In this version of the code, we can see where the while loop is, which is constantly updating the position and velocity of the ball. We have also set drag to be 0 in order to simulate zero air resistance. Notice the steepness of the slope. For this version of the code, you can see that we have set drag to be 0.2 in order to simulate air resistance. You can see that the slope is less steep than the previous model. This is because the air resistance is pushing the object in the opposite direction of gravity, causing it to fall at a slower rate. Now, as you can see, the slopes for all three trajectories are negative and follow a similar path. However, they do differ to a certain extent. The yellow line difference can be explained by the zero drag acting on the object. The blue and red line should theoretically be the same, however, as they are both affected by air resistance. One reason for this could be an incorrect drag value. It's possible that the drag value needs to be higher or lower to better match the observed trajectory. Another error could be an incorrect importation of data while making the graph. Google Sheets is unnecessarily complicated. So what does it all mean? Well, here we can see that the velocity of the object, both with and without drag, have negative slopes. This shows that the object does not reach terminal velocity. One experiment we could design to determine the terminal velocity of the object is by dropping the object at a greater height and calculating when the force of gravity and the force of drag are equal, which would provide a net force of 0. If the object were initially thrown straight up with the same initial speed as in the original experiment, the time it would take to reach the ground would be longer. To determine this, we would add the total time it would take the object to go up and the total time it would take the object to go down. This would result in a longer time because while going up, there will be a point where the velocity of the object will be 0. This will cause extra time to be added to the overall duration of the experiment. And that is the end of the Lab 2 report. Thank you for watching.